Hi, today we are looking at reviewing normal forces and components of gravity. As a reminder, a normal force is the force that a surface exerts. So if this is the force that a surface pushes back against an object to prevent the object from going through that surface. So for example, if I'm standing on the ground, force of gravity is pushing me down, there'd be an equal force normal push me upward so I wouldn't go through the ground. Now, our normal force is always perpendicular to our surface. Now, in Physics 11, you dealt with normal forces on horizontal surfaces and inclined planes. So we'll do some review of each of those. So for horizontal surfaces, unless we have other forces acting on angles, the only force acting on an object are gravity and the normal force. And in this case, the forces will be equal in magnitude and opposite direction. So a quick diagram of this so we can see that if we have this box sitting on a flat surface, we have a force of gravity going downwards, and going in the opposite direction with an equal magnitude, we have our force normal. So look at an example. We have a 25 kilogram box sitting on a horizontal surface. We want to know what normal force is acting on it. So I'd start by writing out some information that we know. So we know our mass is 25 kilograms. We also know that acceleration due to gravity is negative 9.81 meters per second squared. We could also use newtons per kilogram there too. Now, because it's just sitting on that surface, we're not told it's accelerating. We know our sum of forces is 0. Now our sum of forces is all the forces acting on our object added together. So therefore we can say our sum of forces is our force of gravity plus our force normal. Now we want to solve for force normal, so I would move the force of gravity to the other side of our equation by subtracting it. Now we know our sum of forces is 0, so we can get rid of that term. So negative force of gravity equals our force normal, or negative mg equals our force normal. Substitute our values in. You'll find that our negatives cancel out, which makes sense because in this case our force normal should be upwards, which would be a positive value. And calculating going to appropriate amount of significant figures, we get an answer of 245 newtons. Now looking at normal forces on inclines. To solve these, we tend to break the force of gravity into two separate components, one being a force perpendicular to our surface and one being a force parallel to our surface. So force perpendicular to a surface, I usually use the subscript that is two lines that are perpendicular to each other to represent this one. Now this force perpendicular is equal in magnitude and opposite direction to our normal force. So if we calculate our force perpendicular, that gives us our normal force. We have a force parallel, which I use the subscript of two parallel lines, and that's parallel to our surface. So this is the force that pushes our object down our inclined plane. Now I have all of this drawn out on the next slide. So we can see if this is our inclined plane with our box of mass m sitting on it, we have a vector going straight down from it, which is our force of gravity. We can break that force of gravity into two separate vectors, which also are drawn there. So we can see our vector that's parallel to our surface, which is our force parallel, and we also see one that is perpendicular to our surface, which is our force perpendicular. You'll also notice that the angle of incline and the angle that we create at the top of this triangle from our forces is the same. So we'll do an example. We have a 45 kilogram box sitting on a plane inclined at 30 degrees above the horizontal. We want to know what is the normal force acting on this box and what will the force parallel to the incline be. So in other words, we want to know our force perpendicular and our force parallel. Now with this type of question, the first thing I tend to do is draw out our situation. So we have an inclined plane with a 45 kilogram box on it. At this point, I would draw in our forces. So we have straight down our force of gravity, and then we can break that up into a force perpendicular and force parallel. And once again, the angle up at the top of that triangle is the same as our angle of incline. Now I've chosen to solve for our force normal, which is our force perpendicular first. So our force of gravity in this case would be the hypotenuse of this triangle, while our force perpendicular would be the adjacent side. So that means that I would use cosine. So we have cosine is our adjacent side divided by our hypotenuse. Or if we substitute our sides in, cosine of our angle is equal to our force perpendicular divided by force of gravity. Now we know force of gravity is just mg, so we can say cos of our angle is force perpendicular divided by mg. Now one thing to note is when dealing with inclines, I usually don't enter in a negative for our gravity simply because we are no longer following a Cartesian coordinate system, as our force parallel and force perpendicular are no longer lining up with an x or y axis. So if I rearrange this equation by moving mg to the other side by multiplying it over, that gives me mg cos theta is my force perpendicular. So that's 45 times 9.81 meters per second squared times cos of 30 gives us our force perpendicular. And that gives us 382 newtons. However, our 45 kilograms was only two significant figures, so we have to round it to two significant figures. And like we talked about earlier, our force perpendicular is also equal to our force normal. So we have our force normal, now we just need to get our force parallel. Now if we look at that triangle again, our force parallel is our opposite side. We have force of gravity acting as our hypotenuse, so I would use the trig function sine. So substituting in our forces, that gives us sine of our angle is equal to our force parallel divided by force of gravity. As we've talked about, force of gravity is just mg. And we want force parallel on its own, so we'll multiply both sides of our equation by mg. At this point, we'll substitute our values in and calculate our answer. We get 221 newtons, but once again, we need to make sure it's to appropriate amount of significant figures, so we get 220 newtons. Okay, next example, we have a 15 kilogram box sitting on an inclined plane. That box experiences a normal force of 45 newtons. We want to know what is the angle of the incline. So once again, I'd start by drawing out our situation. So we have a box sitting on an inclined plane. And once again, I'll draw the forces acting on it. So force of gravity, which can be split up into our force perpendicular and our force parallel. Now, if it has a normal force of 45 newtons, we know that our force perpendicular is going to have a magnitude of 45 newtons. So we can calculate our force of gravity, which would give us two sides of this triangle, which is enough to be able to solve for an angle. Now, our force of gravity is our hypotenuse, while our 45 newtons, which is our force normal or force perpendicular, is our adjacent side, so I would use cosine in this case. So we know cosine is our adjacent side over our hypotenuse. Now if we want to get our angle on its own, we change it to arc cos of our adjacent over hypotenuse. And we know our adjacent is 45, while our hypotenuse is force of gravity. We know force of gravity is just mg. We can substitute our values for that in, and calculating our angle, we get 72 degrees. Okay, so next we are going to start integrating some force of friction and look at some acceleration. So force of friction, remember from physics 11 that our force of friction is our coefficient of friction times our force normal, where the Greek where mu is our coefficient of friction and is unitless, so it has no units associated with it. And if you recall, or force of friction will always oppose motion. So we'll look at an example. We have a 25 kilogram box is on a plane inclined at 30 degrees above the horizontal. There's a coefficient of friction of 0.10 between the plane and the box. We want to know what is the rate of acceleration of the box. So once again, I would start by drawing out our situation. So we have our box sitting on this inclined plane. We have our usual force of gravity going straight down. We have which can be split into our force perpendicular and our force parallel. What we're also adding in this case is a force of friction. So it's going to be pulling up the plane because our force parallel is going to be moving the box down the plane. Now, if we look along our movements for the box, it's along our plane. So when we look at sum of forces to figure out acceleration, we're just looking at the ones along the plane. So the ones along the plane of motion would be our force parallel and our force of friction. So we can say sum of forces is going to be equal to our force parallel minus our force of friction. Now, we're going to have to figure out what our force parallel is as well as our force of friction, or come up with equations for them. So starting, I will look at force parallel. So my force parallel is my opposite side. We know force of gravity is our hypotenuse, so I'd use sine. So filling in our two forces, we have sine of our angle is equal to force parallel divided by force of gravity. Rearranging this to get force parallel on its own, we get force of gravity times sine of our angle is force parallel. We can substitute in mg for fg. So that gives us mg sine theta is our force parallel. So we have an equation now for our force parallel. So next we need to figure out an equation for our force of friction. We know our force of friction is our coefficient times our force normal. However, at this point we don't have our force normal, so we'll come up with an equation for that. We know our force normal is equal in magnitude to our force perpendicular, and our force perpendicular is the adjacent side of our triangle of which we have force of gravity as our hypotenuse, so I will use cosine. So we have cosine is adjacent over hypotenuse. So we have essentially cos is equal to our force perpendicular over our force of gravity. Rearranging that by multiplying both sides by force of gravity, we get force of gravity times cos of our angle is our force perpendicular. We can replace our force of gravity with mg, and we know that our force perpendicular is our force normal. So we can take our mg cos theta, which is our force normal, and substitute it into our force of friction equation, which gives us our force of friction is our coefficient times our mass times gravity times cos of our angle. So now that we have an equation for our force of friction and an equation for our force parallel, we will substitute those into our sum of forces equation while also substituting in mass times acceleration for our sum of forces. So that gives us mass times acceleration equals mass times gravity times sine of our angle minus our coefficient of friction times mass times gravity times cos of our angle. What you'll notice is all three of those equations have mass, and not only is it mass, it is the exact same mass. So because it's the same mass, it can cancel out of all three terms, which leaves us with our acceleration is equal to gravity times sine of our angle minus our coefficient of friction times gravity times cos of our angle. So we'll substitute our values in, and we get an acceleration of 4.1 meters per second squared.